video on revision and second time work. I just want you to know that this video is actually tailored for St. Finbarr's College students that are writing their SS2 second time examination, but it can still be useful for any Catholic student, whether you are male or female. So there is something I just want to give you here because we are using a general scheme of work. So for you, before you write your exam, I would actually like you to watch this. What I'm going to be looking into is separation techniques, kinetic theory of gas laws, electronic configuration. Sometimes we can even call it electron configuration, isotopy and allotropy. You need to have that. Percentage by mass of element in a compound, acid, base, and salts, periodic table, which we just did last time, redox reaction, which we also did last time, electrolysis we did last time, description of laboratory preparation of gases, which is current term, and ammonia and sulfuric acid industrial preparation, current term, and water and solubility. And the last one is chemical equilibrium. This chemical equilibrium, majorly, the Catalan's principle is what I'm expecting that they are going to use, where they are going to be presenting to you something in the nature of asking you a question to tell the effect of catalyst, temperature, pressure, and concentration. So they can use something like formation of ammonia or formation of sulfur 6 oxide. They can use something like that. Each of them are isotonic. You just need to understand the idea that if we are talking about increase in temperature, it will favor endothermic part of a reaction. You just need to know that. And endothermic part of the reaction, we know it if, for instance, the change in heat is positive. That means that the forward reaction is that endothermic part of the reaction. So if you increase temperature and you have the change in heat to be positive, then you know that the forward reaction is going to be favored, vice versa. So if you increase pressure, you are going to favor the part that have lesser molecule if all are gases, because pressure only work on all gases. So if you increase pressure, it's going to favor the one that have low number of moles, which we convert it to volume. That means that it's going to have lower volume, following the idea of Boyle's law. So you have to know that if we are trying to look at concentration, if you start to remove from the product, we will have more formation of the product. If we start to add the reactant, we have more of the product. Okay, if we start to remove from the reactant, we'll be having more of the reactant. If we start to add more of the product, we'll be having more of the reactant. But first of all, I want to start this revision from separation techniques, what we did in SS1, and you need to look at what I'm expecting you to know about separation techniques, a process of recovering components of mixtures by taking into account the unique component physical properties. That means that each of the components has its own unique properties. For instance, we can have something like ammonium chloride and sodium chloride. Ammonium chloride, when you heat it, it is going to sublime. But sodium chloride, when you heat it, highest it can do is it will melt. So subliming means it's moving from solid to gas. So this is a unique property of ammonium chloride. So we can use sublimation method to separate ammonium chloride from sodium chloride. Don't if you understand me on that. So this is the unique property of ammonium chloride. So we use this unique property of the components of the mixtures to separate them. I have crystallization. I just want you to look at the diagrams. Yeah, in the step 1, for us to do crystallization, we actually add the solid inside a solvent and dissolve it, and we will heat it. This step 2 is a diagram that can also represent evaporation. Yes, this diagram can represent evaporation. You need to know that. So it is being cooled, and in step 3, after being cooled, you start to see the pure crystal appearing, as you can see in step 4. So when we talk about crystallization, what we actually mean is a process of recovering solid components of mixtures by heating the solution to saturated solution and allowed to cool. What we mean by saturated solution is when we heat it, some of the solvent will leave the solution, making the solute to be more concentrated. What I mean by more concentrated is that we will have more of the solute than it was before in ratio compared to solvent. See what I mean here? If the solute was before 5 grams and the solvent was 5 grams, if we heat it, you know that the gram of the solvent will decrease. Let's say that the gram of the solvent is reduced to 3. You see, before it was 5:5, now it will be 5:3. So we are having more of the solute than it was before compared to the solvent. And they will be at a point where the solvent can only contain it will reach at a point where the solution contain the maximum amount of solute it can dissolve. That is what we mean by this saturated solution. You need to know that in crystallization, when this is being cooled, you start to see the formation of the crystal coming out. We normally use it in drug preparation, sugar production, because of the need of its high purity. So let's look at another one, sublimation. If you go back to this crystallization, I said something about step 2 being evaporation. If, for instance, we add this evaporation, this inverted tube or inverted funnel, we are going to have what we mean by sublimation. And sublimation is a process that we use to separate solid that changes to gases directly when heated. That is, they will not pass through liquid, they will just move direct to gases. Something like ammonium chloride, iodine, something like naphthalene, something like camphor. When you heat them, rather than them to melt, they sublime. So we can use this method to separate ammonium chloride from sodium chloride. As I said earlier, this is something you need to grab it. Remember that I just added inverted tube, or I prefer, if you are a Catholic student, know that this inverted tube, you better use inverted funnel. And you need to add cotton wool or cotton plug, as you just see over here, in order to prevent that gas escaping. So we just do it like this to cover it, so that the gas will be collected and form the solid over there. We have separating funnel. Separating funnel is mostly used to separate two immiscible liquid. It means the possibility of them being of different polarity is high. It is mostly used to separate non-polar, that is not soluble in polar. So when we have non-polar in polar, it will aid in separating them using separating funnel. Majorly, what I mean, example of non-polar is something like kerosene, as you can see on the screen. An example of polar is water, so we can actually use that to separate them. And here, the heavy substance or the heavy liquid will be down and the lighter will be up. So separating funnel is a method that we use in separating components of mixtures that do not mix, like polar liquid and non-polar liquid. Example is water and oil. So we look at distillation. This is used to separate miscible liquids with far difference in boiling points. So if they have far difference in boiling point, we can actually separate them. Don't mind the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can even look into them like this: heat 1, 2, that is a round bottom flask, including 8 being the round bottom flask containing the distilled solvent or distilled substance, and the 3 represent the connector, and the 4 represent the thermometer. The inlet and outlet is 6 and 7. So those ones are not major important. You can use your textbook to put up all the values there. So you need to know that example of this is ethanol in water, and this is even applied in brews. So that's the use of this distillation. We have a senior brother to distillation called fractional distillation. The only difference between this diagram and the previous diagram is that this first diagram does not have this particular one does not have fractionating column, but when we look at this one, we have a fractionating column before you see the thermometer. So this is the difference in diagram, and this is used to separate miscible liquids with close difference in boiling point. So it is something that we can use to separate miscible liquid. And when we hear miscible liquid, it means that they might be of polar or non-polar. I hope you get me on that. So the boiling point is close, something like, the differences might be just something like 10 degrees Celsius different, but for that far boiling point, it can be something like 20 degrees Celsius above. Hope you get me on that. That fractionating column there is actually doing the work of helping the fractions that have reached its boiling point to actually be produced, then descending the other one that have not been, so that the Libya condenser can actually carry out the distilled form of that fraction. So I need you to know that we use this in petroleum production. We even have oxygen and nitrogen production in the industry. We use this idea. We call it fractional distillation of liquid air or liquefied air. So you need to know that paper chromatography, you need to know paper chromatography. Paper chromatography is mostly used to separate colors. Something like dye, ink, and so on. I hope you get me on that. So we have kinetic theory of gases. If you listen to my song about it, a gas molecule are in constant random motion in a straight line moving with perfect elastic collision. You can watch my video on the song and listen to the song and grab it. I believe highest they can ask you is 3. They will not ask you more than 3. That is stating the postulate of kinetic theory of gas. In Boyle's law, you need to understand what we mean by Boyle's law, and Boyle's law has to do with volume and pressure. As you can see, that you need to know that Boyle's law, you need to do Charles' law, and also look at the diagram I represent here. If for instance we are plotting P against V, it is going to be curved. If for instance we are plotting V against P, it's going to be curved. But if for instance we are plotting P against 1 all over V, is going to be a straight line. If for instance we are plotting 1 over V against P, we are going to have a straight line. The same thing goes with Charles' law graph. If for instance we are plotting V against T, we are going to have a straight line that is touching the absolute 0. The absolute 0 is minus 273. At this absolute 0, in Kelvin, it is 0 Kelvin. There is no energy. Yes, so all energy has been reduced. Remember that according to kinetic theory of gases, the average kinetic energy is equal to the temperature, although they are proportional to each other. So you need to know that. Also, I want you to look into electron configuration. In electron configuration, you need to know how to write electron configuration using the SPDF. As you can see in my diagram, you need to know the electron configuration using the SPDF. And also, whenever you see electronic configuration written for you in SPDF, the first thing I urge you to do is to convert it to electron configuration using the K element, just as you see in my 286 down here, okay, or the normal shell. So from this place you can be able to visualize how the period will be, what the period will be, and what the group will be. For instance, 286, that number 6 denotes that it is found in group 6. 286 has red, blue, and green, 3 circles representing 3 shells. And if we have 3 shells, it means that this is third period. So from this idea of using K element, you can be able to predict the group, you can be able to predict the period. So you should be able to know how to write both the SPDF and K element of a given atom or element. They can give you something like sodium, they can give you something like silicon, so you need to practice that. They can give you something like carbon, chlorine, or calcium, you need to practice that. They can also ask you a question like, what would be the charge of sulfur? You can do the same thing with silicon, you can do the same thing with sodium, you can do the same thing with calcium, chlorine, and carbon. They can ask you what would be the charge of this and what type of bond do you think that they can form. Let's just focus on sulfur and sodium. For sulfur, the charge of sulfur is going to be -2 because it needed 2 to complete this is or state. So it needed 2, so it's going to be -2. If the valency is going to be 2. Now, the type of bond it forms, when it reacts with non-metals, it will form covalent bonds. But if it reacts with group 1 or group 2 element, it is going to form what we call ionic bond. Note that if for instance this 3p4 is 3p6 and there's no other orbital there, we can render it as a noble gas because it has a complete duplet state or octet state. Something like that is noble gas. Something like helium, neon, argon, krypton, they do have something like that. That means that they are unreactive. You need to know that. So use electron configuration to predict period, to predict group, the type of bond the atom can actually form. As I have just said, You should also be able to predict the property of an element. For instance, group 1 elements, they behave like metal because they are capable of releasing electron because their atomic shell is below 4. But that of group 5, 6, 7, they are not capable of releasing electron. Rather, they love accepting electron. So we can call them non-metals because metals are those elements that is able to release electron when they form ions, whereas non-metals accept electrons when they form ions. So you need to know these little things and more. You also need to know isotopy and allotropy. It is very, very important. So here you should be able to give examples like telling them that isotopy, which you know is existence of atoms of having the same proton number but different mass number due to differences in neutron. So example of that is hydrogen and chlorine. You can add up something like carbon and oxygen. Calculation of relative molecular mass from isotopes of elements are also important. Something you can see in one of my videos. There's one of my videos I just uploaded for SS1 students that are preparing. You can also watch that, you can get that, or you can just look at this. If for example they give you chlorine 35, chlorine 37, they can give you the percentage. Maybe they will say 35 is 75% and 37 is 25%. Just use that 75 multiply the 35, use the 25 multiply the 37, add them together and divide it by 100, you will get that. You also need to be able to know what allotropy is and give examples to it. You know, allotropy is the existence of elements in the same physical state but having different forms. So examples of them are carbon, oxygen. Now look at a game here. In isotopy, I have carbon, I have oxygen. In allotropy, I also have carbon, I have oxygen. So you make it easier for you to connect them. Other ones are sulfur, phosphorus, and tin. It is possible they can ask you to list 3, but I don't think they can ask you to list 4. But if it is somebody like me, I can even tell you, apart from tin or apart from phosphorus, give me other 3. Yes, I can do something like that. Means that you need to grab these forms that I have just dropped down for you. So do you know how to calculate the percentage by mass of an element in a compound? For instance, if you have sodium hydroxide, sodium is Na, oxygen O, and H is 1. So you have H is 1, oxygen is 16, and Na is 23. If you add it together, it will give you 40. Then when we want to calculate the percentage of sodium in sodium hydroxide, we're going to have 23 all over 40 times 100. You will get that. So do you know empirical formula? Can you define empirical formula? Can you define molecular formula? Can you differentiate between empirical and molecular formula? Can you actually calculate or find empirical formula of a compound given to you? Can you actually calculate its molecular mass? It's also important. You need to do that. I want you to take a look at my video on SS1. You can also see that. You should be able to differentiate between acidic salt and acid anhydride with examples. Acidic salt are salt formed by partial replacing of replaceable hydrogen. Example of them is sodium hydrogen triisocarbonate 4, sodium hydrogen tetraoxosulfate 6. We even have that calcium hydrogen triosonitrate triosocarbonate 4, magnesium hydrogen triosocarbonate 4, which you know these two we actually see it in hard water and in temporary hard water. So that's example. Acid anhydride are those substances that when they dissolve in water they will form an acid, something like hydrogen chloride gas. If it dissolves in water it becomes hydrochloric acid. We have sulfur 4 oxide, sulfur 6 oxide. When they dissolve in water they will form acid. So you need to know that with that example I just listed there. You should be able to differentiate between hygroscopic, substance that absorbs moisture from the atmosphere and it will not dissolve in it or form a solution, but the liquid sense they will absorb moisture from the surroundings and they will form solution with it, whereas efflorescence, if you expose them to sun they will lose their water of crystallization. For hygroscopic, I always tell my students use tetraoxosulfate acid. For the liquid sense, use sodium hydroxide. For efflorescence, use sodium or washing soda, sodium triosocarbonate for the carbohydrates, or just call it washing soda. You can use that. That is what I do tell my students to make it easier. Do you know what we mean by basicity of an acid? The number of replaceable hydrogen that is present in an acid. I need to get you informed on this. For organic acid, something like ethanoic acid, there is only one COOH, so we say it is monobasic. If we have it as if you have two COOH, that is, you have COOH and COOH, then we can say it is dibasic. And you know that all the hydrogen in inorganic compound are replaceable. So you need to also know what we mean by alkalinity, the degree of base or hydrozonium, the degree of hydroxide ion in a solution. So you should be able to differentiate between the pH value and pH scale. pH value is actually the negative logarithm of the hydrogen ion concentration present in a solution, whereas the pH scale is that scale from 1 to 14 that denotes the degree of acidity or alkalinity of a solution. You need to know that. Anhydrous and hydrated substance. When we say anhydrous, it means that there is no water. When we say hydrated water, it means that there is water there, and that water forms water of crystallization. So you need to know that. Do you know your periodic table? Can you define it? Do you know your trends? The trends, something like ionization energy, electron affinity, electronegativity, metallic property, atomic radius, atomic size, ionic radius, ionic size. All those things are important. That's what I mean by trends. You need to know how they move in the periodic table. Also, state the periodic modern law is important. Do you know your redox reaction? You know, redox comes from reduction and oxidation reaction. Can you be able to define reduction or oxidation? Let me just speak oxidation. Oxidation in terms of oxygen is adding oxygen. Oxidation in terms of hydrogen is removing hydrogen. Oxidation in terms of electron transfer is losing electron. And oxidation in terms of electronegativity value is increase in decrease in electronegativity value. But oxidation in terms of oxidation state is increase in oxidation number. You need to know that, and you also need to know how to calculate oxidation number or state in a compound. So you should know your electrolysis, define electrolysis, the two laws from the Faraday's, and how to calculate them. But there's just something I want you to note here. Know that silver and group 1 elements charge is +1. Zinc, copper and group 2 elements are +2. Scandium and group 3 elements are +3. You need to know that when you are doing your calculation in first law of Faraday. So you also need to know how to prepare hydrogen, how to write the equation. You need to write just telling how to describe it. If they say you should describe and they do not tell you use diagram, you can just tell them, for instance, hydrogen, that dilute acid is added to zinc to give us zinc chloride and evolution of hydrogen gas, and it's being collected over water. You have actually described that. If they say the description is 3 marks, you have gotten your 3 marks. Since they do not ask you to use equation or use diagram, you have described it. But if they ask you to use equation, you need to write the equation of just what I said now. The same thing goes with if you are being asked that of oxygen. You should be able to do the same thing, that manganese dioxide is acting as catalyst. Then the hydrogen peroxide, when you add it to the hydrogen manganese dioxide, it is going to quicken up the production of oxygen. You need to know that. So for delivering, if for hydrogen gas, another way of delivering hydrogen gas is upward delivering and downward displacement of air. But oxygen, because it's denser than air, we will do it as downward delivering and upward displacement of air. But the thing here is that oxygen is just slightly denser than air, and two of them are insoluble, both hydrogen and oxygen. Now you should also be able to give at least 3 properties of hydrogen and oxygen, both the physical and chemical properties. If you write those things down and practice them, look into your chlorine and nitrogen, the preparation too, and also give two example of their properties. Practice it just practice it 40 minutes every day before your exam. You will see that you will do very, very well in your exam. The next thing is contact process. We also have another one called Haber process. Haber process is the production of ammonia using hydrogen and nitrogen. And the first person that actually used this pattern is called Haber. So we call it Haber process. But if you can see this place, we call it contact process, where sulfur is roasted in oxygen and the sulfur 4 oxide form is being catalyzed by vanadium 5 oxide, which we place it inside already made tetrodorsophases diluted, and we're going to give us oleum in part 4. In that part 4, the next thing we're going to do is to add water to it. We give us tetrodorsophases acid for the commercial use. The reason why we don't add this SO3 directly to water is because of the reaction is highly exothermic, so it's going to form fumes in water directly. So they first of all dilute it with inside the already prepared acid. And I want you to also look into water. Hard water. What we mean by hard water, it does not lather soap easily, and we have temporary and we have permanent, and you should be able to give ways of softening hard water, 2 ways of softening hard water, or 3 ways. Something like if they ask you something like this, 2 ways or 3 ways of softening hard water, I believe they will use two ways. For temporary, we say use of boiling. 1, use of boiling. The second part is going to be use of calculated slick lime. That is for temporary. For permanent, you just tell them use of caustic soda and use of washing soda, use of resin. I have given you 3 here, so any of them that you remember, you can pick them. But if you watch this video over and over again, you will pick all those points in your head and you can do well in your exam. You need to know the calculation in solubility. Watch my video on solubility, please, so that you will grab more information from this calculation in solubility. But just know that it is all about mass all over molar mass times volume. If you can record that, it will be easier for you. The temperature has no much meaning. Yes, the temperature has no much meaning. Thank you very much for watching this video to this extent. I just want you to know that I love you and I wish you a success in your exam.